rectifier circuit. What is a rectifier circuit? One that converts AC to DC. That's what the word rectification means, converting AC voltage to DC voltage. Okay? So, there's two kinds of rectification. There's half wave and full wave. We're going to talk about half wave first, and then we'll talk about full wave. So, you see where it says half wave rectifier circuits? Can you write down, right beside that title, 1D? Can you write down 1D beside that title? 1D for one diode. So it takes only one diode to build a half-wave rectifier circuit. Okay? So I have PowerPoint notes on half-wave rectifier circuits. You can look at that. However, I'm going to do the theory and the example simultaneously. So what I'm going to have you do is draw a circuit diagram in the box that is on page 1. So let's start off with the circuit diagram of a half-wave rectifier circuit, a typical half-wave rectifier circuit. We start off with a transformer. So let's draw a transformer. So the transformer has 120 volts, 60 hertz, connected to the primary side. This is RMS. The transformer has a turns ratio of 15:1 to step the voltage down. So I write down 15:1 here. So it's by that ratio that I reduce the voltage on the secondary side. So I label the other side secondary, and I calculate the secondary voltage. So let's do that calculation first. So the first calculation at the bottom, item A, is V secondary RMS. So what I want you to do is get in the habit of showing calculations during the labs, showing calculations during homework assignments, and showing calculations during a test in 3 parts. When you are looking for a calculation, the first thing you're going to specify is the formula. So the formula for solving V secondary RMS is V primary RMS, what? Divided by ratio. So we're stepping the voltage down by 15. So that's what the formula is. So I take the 120 volts and I divide it by 50. So that's my second item that I do for calculation. So these are values. I substitute values in my formula. And the third part is the answer. Okay, so you want to do all calculations in 3 parts. First you show the formula, then you show the values in the formula, and then you show the answer. So what is 120 divided by 50? 8 volts RMS. Now, you guys are doing electricity, and you're doing RMS calculations, you're doing peak calculations, peak-to-peak calculations, or AC voltages, one thing that you've learned is RMS is something that you measure on a multimeter. That's what RMS will give you. A multimeter will read an RMS value. So I'm going to put a little picture of a meter and indicate AC. Okay, so that's what you're going to read on a multimeter. You take a multimeter, you connect it at the secondary, and your turns ratio is 15:1, you'll read 8 volts. Okay. Now what I'm going to do is complete my circuit. So what I do is I place a diode here. And that's it. That is a circuit that will convert AC to DC. The diode will change the sine wave into a pulsating DC voltage. So let's explain how that works. Let me first show the load connected here. So this is the load. The question says that a 1K ohm resistor load is connected to the circuit. So this is 1 kilo. Okay. So let's see what's happening now. I start out with a sine wave here, which looks like this, right? That's on the primary side. What happens on the secondary side? It gets reduced to a smaller size, so it becomes this, right? Is it still a full sine wave on the secondary side? Yes, it is. What is the sine wave made up of? A positive half and a negative half. Everybody see that?